first one, a three-sided polygon, is called a triangle. A four-sided polygon. Does anybody know?
Yeah.
Jennifer? Close. Yes. Quadrilateral. And there are very specific types of quadrilaterals, and we're going to get into that in a couple days. A five-sided polygon. William? Pentagon. Just like the building. Six-sided. Johnny? Hexagon. Good. Seven-sided? Anybody? It's a heptagon. Heptagon. Eight-sided. Anthony? Octagon. Nine-sided. Jaime? Good. It's a nonagon. I like that one. I think it sounds cool. A 10-sided polygon. Scott? A decagon. Like a decade is how many years? 10. So a decagon has 10 sides. 11. Scott, you think you know it? Nope.
Oh, wait, no.
There's actually two names for it. The first one is an undecagon. And the second one is a hen decagon. So undecagon or a hen decagon. 12? Scott? Dodecagon. And then this N down here means that anyone after 12, so 13, 14, 15, 16, any of the ones that are after 12. So for an example, if you want to write this as an example for 13, it's just a 13-gon. So you write the number, you put a dash, and you put gon after it. So 14-gon, 15-gon. And they have specific names for a 100-sided one or a 1,000-sided one. I don't know them. So they're actually on the iTouches, so next time you guys get on those, you can watch them. What I want you to do right now is star the ones that I'm going to star up here, because these are the ones that you absolutely have to know. You need to know a triangle. You need to know quadrilateral, pentagon, hexagon, octagon, decagon, and that's it. Now we're going to the half sheet of paper that you guys have. The first word on there is polygon. There are three parts to this definition. The first part, a polygon, is a closed geometric figure. By closed, I mean it cannot have an opening. Okay, so this example up here, this is not a polygon because it's not closed. So it has to be closed. The second part of it, in one plane, means that it's 2D. Means you could draw it on paper. Okay, so two-dimensional, in one plane. And then the last part of the definition is formed by connecting segments endpoint to endpoint. This is the reason why a circle is not a polygon. It does not have segments in here. It's a circle. Okay? Same with this one right here. Anytime you see a curve in a shape like this, once you see a curve, it is no longer a polygon. Polygons cannot have curves. Once you see a curve, not a polygon. So I want you guys to draw one example of a polygon, so you can pick one of these up here and draw it underneath. So just real quick one if you want to. So you can put a check mark next to it, polygon, and then you could just simply draw a circle, put an X through it. So you know a good example of a polygon and a good example of not a polygon. Next two definitions are convex and concave. For convex, a convex polygon is a polygon in which no diagonal can be drawn outside of the polygon. Meaning, if you have all of these vertices here, So I'm just making them so you guys can see them better. If you connect any two of these, so if I go from here to here, or here to here, or even here to here, or here all the way across to here, you will never have a diagonal. You'll never have one of these that goes outside of the polygon. That's called convex. It's easier to do concave first, so let's jump down here to concave and we'll kind of jump back and forth. Concave, if you look at the word concave, it has the word cave in it. That's helpful. Anytime you have a polygon and you can make a little cave somewhere, so for example, if I look at this one and I take this vertex and this vertex and I connect those, I've now made a cave. So a little person could sit in here and he can sit on the polygon without sliding off. That's concave. Okay, so if you can take any two points, not any 2 points, if you could take 2 points and when you connect them, the diagonal is outside of the polygon, that's considered a concave polygon. You form a cave. If you cannot form a cave, so all of these up here, you cannot form caves, it's called convex. We have to talk about what a regular polygon is. So you guys have this on your paper. A regular polygon is a polygon with all congruent sides and all congruent angles. The best example of a regular polygon is a square. So if let's see, nope, that's a rectangle. Here's my square. Okay, so the best example, it's a quadrilateral, but it's a specific type of quadrilateral, is a square. All the sides of a square are congruent. All of the angles of a square are 90 degrees. That's the definition of a square. Of a regular polygon. You can have a equilateral triangle. Let me grab my triangle one. And that would also be considered a regular polygon as long as it's equilateral, which means all of our sides are congruent. In turn, all of our angles are going to be congruent. So those are two examples, but you can also draw, so if I just tried to draw a pentagon here. Oh, that's close, but you get the idea. If I say that all of these sides are congruent, then this would be a regular pentagon. So for these ones up here, I'm not going to make you draw them, but I am going to have you guys answer a couple different things about them. One vocab word we haven't really talked about yet was symmetry, which is also referred to as a line of symmetry or symmetric. You need to know all of those, but it's to have the exact mirror image on both sides of a line of symmetry. So for example, if I assume that this is a square, I think it's meant to be, which means I can draw a line of symmetry here, here, and on a square, you can also have a line of symmetry here and here. That does not work for a rectangle. Remember, we took the piece of paper of a rectangle and we folded it on the diagonal. It did not match up. It does match up with a square. Okay? So in this case, the name of this polygon is a what? Besides a square, if you just go by numbers. Quadrilateral. So on your paper, you're just going to write number 1. I don't want you to draw it. And you're going to write quadrilateral. You're going to tell me if it's regular, just put an R there. Number of lines of symmetry. So we had 1, 2, 3, 4. So I'm going to put the number 4 for 4 lines of symmetry. And then I want you to tell me if it's convex or concave. So is this convex or concave? Convex. It's convex. So there are 4 things, possibly 3 things, because if it's not a regular polygon, just don't write the R. Okay? So for this one here, you need to, let's count this together because it's kind of hard to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So what's this one called? A 13gon. And then you guys, let's just finish the rest together. Is this regular?
No.
No. How many lines of symmetry does this one have? Just 1. And then is it convex or concave? Concave. concave. You can form all sorts of caves in there. Questions on what you're doing for the last 4? So again, guys, you don't have to draw these. If you want to, go for it. I just want you to answer these 4 questions for those, and then we'll go through the answers in a few minutes. Yeah, trick you. Questions? All right, I have a couple more for you guys to work on.